Okay, let me go over the calendar that we have here. So we're finishing up the second half of this unit, and the big topic from this whole unit is something called differential equations. So differential equations, the idea is that now we're going to be taking the antiderivative on both sides of our of the equal sign. But so far, we've just been doing everything on the right side. Right? We just want to find the antiderivative, but now we got to deal with on the left side. It's going to extend the problem a little more. But historically, students have trouble with this section, not because of the calculus, because of the algebra. So, and the problems are usually a little longer. So I know that this is going to be something that takes time to get used to. So even after we cover our three we'll cover 3 sections between now and Monday, and we'll spend 2 days just to kind of get a lot of practice in. The more you see, the more comfortable hopefully you'll be. And then we have one more integral rules, set of integral rules to know, and then we'll do test review Friday as well as Wednesday after we get back from break, and then our test is scheduled for the Thursday after break. Okay, and then after that, then this is our final unit. Okay, and our final unit will just be 3 sections. So I think that final unit will just make it a quiz, and then by mid-March we're going to start trying to put all of the review topics together and start getting into that AP review form. Yeah.
Is there a final?
There's not going to be a final, but I will have kind of mock AP tests, but I'm going to split it up over the course of multiple assessments. So it'll just be a combination of quizzes and tests. But all those tests and quizzes during the AP review will be buffered by your homework grades. So your homework grade will go into your test grade. So that'll help balance things out. Okay, so let's go into page 1. So differential equation. Okay, so all a differential equation is it's a derivative equation. That's all it is. It sounds complicated, but it is just a derivative equation. So basically something that is in the derivative level, and we're just taking the so when we're talking about solving differential equation, all it means is we're going to take the integral to get from the derivative up to the function level. And that's all it is. It's not anything really new from what we've seen before. We've been doing it. We just now have a specific name for this. And we call it an equation because we're really having to work on both sides of the equation to get us there. So the first step is we want to be able to separate the variables, meaning that things are going to be mixed up. We want to be able to group the x's together, group the y's together, and then we can move into the calculus portion. Okay, so we want to rearrange the equation with the y and dy together on the left side, and then the x and dx, which is the independent variable, on the right side of the equation. Okay, so my suggestion is let's always cross multiply. Okay, that's always the first step that we do. It's not going to necessarily solve anything for us, but it will put everything in the numerator, and I think it's easier for us to work with things we see in the numerator rather than things that we see in the denominator. All right, so we have dy over dx equals 2x over y. We're going to solve this differential equation, but we want to separate the variables first. Okay, so I'm always going to have us do this, cross multiply. Okay. So when we cross multiply, we get y dy is equal to 2x dx. So the nice thing here is, are the y's together and are the x's together? Yeah. Yes. Okay. So there's nothing to move. This is an easier problem. However, we are going to have to take the antiderivative on both sides. Okay. Before, we never had to worry about the left side. We just made it y equals. But now there's going to be something more that we got to worry about. Okay. So we're going to use the integral notation to indicate what we're about to do. It's going to extend the problem because now we got to do calculus on both sides of the equation. Now, let's do the right side. The right side feels more familiar. What rule can we use for the right side? Power rule. Okay. All right. Let's look at the left side. What do you think we can use on the left side? Also power rule. I know it looks strange because we're not used to working with y variable, but you just treat y like you would x, right? If it was x dx, you would do power rule. If it's y dy, you would do power rule. Okay, so let's move on to taking the antiderivative. That's fine. We can move to on the left side now that we know that these are just really just power rule. Okay, so y becomes what? Yeah, y squared over 2 plus c. Yes, but okay, all right. We'll do plus c for now. Equals. Yeah. 2x squared over 2 plus what? C. Okay. Now, what we're going to do is we're going to group all the c's together. There's not any reason to have c's in different places because if I merge the c's together, it's still a constant. So from now on, we're only going to write plus c once, and it's just going to be on the right side. Okay. It's not wrong if you have multiple c's, but it just adds to the complexity of the problem. Might as well just get it cleaned up and just have plus c show up once. Okay. Any questions there? Okay. So after we do this, we're basically at the function level. We're done with the calculus. We may just have to do a little bit of cleanup. And what I mean by cleanup is trying to get this down to be in terms of y. So we're going to have to kind of move things away from the left side to get it in terms of y. So how can I get rid of this? Let's deal with this 2 first. How can I get rid of that 2? Yeah, let's multiply by 2, right? So if I multiply by 2, I can distribute 2 through, get the, really, the right side, it doesn't really matter what happens here. It's really the left side we're really trying to clean up. Whatever ends up on the right side, ends up on the right side. The right side is not so important to clean up. It's the left side that we want to clean up. So what's going to happen here? Just becomes what? Just y squared, right? Equals. Yeah, so the 2's cancel out. This 2 will remain, or various 2's can cancel out, but still we're still left with a 2, right? So y squared equals 2x squared plus what? Now 2c is the same thing as what? C. So we don't have to, if there's any coefficient in front, again, it's not wrong if you do 2c, but just for cleanup purposes, there's no need to include anything more than a c if it's multiplied by another constant. Does that make sense? Okay, we're not quite all the way down to y, but it's okay. We'll save that for later problems. Okay, but I just want to kind of begin getting our feet wet in terms of the process that we're going to do. We're gonna separate the variables, get the y's together, get the x's together, take the antiderivative, whatever the rules may be. Right now, we're starting easy. It's just power rule, but down the road, it could be use substitution on both sides and treating them independently. And then once we get it up to the function level, then it's just a matter of, okay, what can I do to get this left side as cleaned up as possible? And that's going to be our solution. Okay. And then we may be asked to solve for C, but to solve for C, you'll be given an ordered pair, and we know how to do that, right? We know how to solve for C. Take the ordered pair, plug in X and Y, solve for C, and then update the equation. So a lot of it you've seen before, it's just now, it just feels like a much more extensive problem because we're having to do algebra before, followed by calculus on both sides of the equation, solve for C, and more algebra at the end. So this is going to sometimes take up a lot of space, even though it's not really anything new that we haven't seen before. It's just we haven't all seen it together all in one problem before. Okay, let's look at example 2. Dy dx equals x over 1 plus y. Now, when you're dealing with the differential equation, the parentheses are there to help you. Okay, so typically we always want to take a pause before we try to distribute too quickly because they're trying to help you separate the variables with the parentheses. So let's not lose the parentheses whenever we're dealing with this differential equation. All right, so the first thing that I want to do is we want to cross multiply, right? Let's get some of the denominators out of the way. So I just feel like it's easier to work with numerators than denominators. So I'm going to put this over 1. And I'm going to cross multiply. So diagonal pairing of terms. So when I cross multiply, I get 1 dy is equal to x times 1 plus y dx. Okay, any questions so far? Now, when you cross multiply, you may not have full separation of variables, but you will have 2 things in place. And those 2 are going to act as your anchor. Okay, so your anchor is going to be your dy and dx. Make sure that your dy is on the left side. Make sure your dx is on the right side. And make sure your dy and dx's are in the numerator. That's important. Okay, it's okay after we change things around that your x's and y's may be all over the place, but just make sure your dy and dx's are in the numerator. Those are your anchor variables. Okay, so those things are set. We're not going to move them. It's other things that we may have to consider moving. All right, good so far. So when we cross multiply, you will have those 2 things set in place. Your dy in the numerator on the left, your dx numerator on the right. Okay, next up, do we have full separation? Do we have y's together on the same side and x's together on the other side? No. Okay. What do we need to move? Good. So the parentheses is helping us. It says that, okay, I know I got to move that y, but the 1 has to come with it because it's inside the parentheses. So where does this have to go? Left side. How do I get it to the left side? Dividing. Okay. So if I divide something, where's it going to end up on the left side? Denominator. Okay. So it's okay to have variables in the denominator. I think sometimes students feel like denominator is wrong, and so they end up letting this float up to the top, and we don't want to do that, right? So wherever it ends up, then we want to let it stay there. Okay, so we should have full separation of variables. I'm going to write it this way. Okay, how about now? Do we have, because we divided over, right? So this got moved. We have full separation. Are the y's together? Are the x's together? Yes. Okay, so now we're done with the setup. We're ready for our calculus portion. Okay, so now we can put our integral notation to indicate we're about to move into our calculus portion. Okay, I just want to observe on the right side here. Right side is just an easy what? Power rule. Okay, so we know that's going to be a straightforward one. This one, you guys tell what's needed here. Yeah, but yes, natural law. But let's say before that, we should do what? A little bit of u substitution. Okay. Now, I know some of us may feel comfortable enough to jump into the natural log without having to go through u substitution, and that's fine. But for now, I'm just going to kind of go through all the steps so that I don't want to take any shortcuts just yet, at least not for demonstration purposes. So we're going to take the time to get that left side because we know we can't expand this, right? This is too messy for one rule. Technically, this is u substitution. So I'm going to work on that left side. So my denominator is my u value. Instead of du dx, now it's du over dy. What's derivative of 1 plus y? Just what? Just one. Okay. Cross multiply. Make our substitution here. Okay. 1 over u du, what does this turn into? Yeah, natural log, absolute value of u, and then replace u back in terms of y. Okay, so I know some of us are pretty confident that they can jump from here to here without any trouble, and that's fine. For now, I just want to show you the full steps. So the left side is accounted for, so we're done with the left side. Let's take care of the right side now. Okay, x becomes a squared over 2. Okay, plus c. Okay, so technically we're at the function level. This is considered some variation of the answer. We have technically solved the differential equation. So if this were a free response question, you would have earned the majority of the points at this stage. You've separated the variables, you've done all the calculus, but the final points in this problem is trying to solve for what? Solve for y. Yeah, so now it's just clean up, trying to figure out how to solve for y. Okay. I'm going to rewrite this because the algebra is going to be a little new for us here. So the idea is that we want to solve for y, and this is not something that we can distribute, right? This is 1 plus y, it's inside natural log. We basically have to figure out, how do I undo this natural log in order for me to get to the y? So we have to basically involve the inverse, right? So what's natural log's inverse? You guys remember? Yeah, e, right? So exponential function and natural log, they're inverses of each other. So the way that we can get that natural log to go away is we can raise both sides with e as the base, because we know that e and natural log are going to be able to cancel each other out. So whatever I do to one side, I'm going to do to the other side as well. I'm exponentiating both sides. I'm moving both sides up as exponents because I really want to take advantage of this e and natural log pairing up and going away. Okay? Because e and natural log have their inverses, so we can take advantage of that property. So now e and natural log can just pair up and go away. I'm just left with what? Okay, 1 plus y with the absolute value still there. Okay. Good so far. Now the right side, there's a specific way that we're going to clean this up. Okay, and we're going to use this property here. The property is exponent property is if I have a base a to the n plus n, I can split that that expression into the product of two bases. This is a algebra property here, exponential property here. Okay, so what would that look like if I were to use this property to split this up? E to the what? Yeah, e to the 1/2 x squared, or x squared over 2 times. That's right. So now you see that plus in the exponent is now going to be turned into a multiplication at the base level. Times what? E to the c. Right. Are we okay so far? Now, what do you think e to the c will represent? Now, e is just a what? By itself, e is just a constant. What's c?
Variable. No constant.
Constant. What's a constant? What's a constant raised to a constant? Still a constant, right? 2 raised to the 4th power, 5 raised to the 50th power, still a constant. So I can just replace this whole thing with what?
C.
Just c. But now it's being multiplied, so it's going to be times c. Okay. So it's going to be e to the x squared over 2 times c. And typically what we do with a constant is we push it out in front because it's a coefficient. So I'm going to now move that c out in front. So far? Okay, we're almost there. Trying to get y by itself. Now, I need to be able to deal with the absolute value bar. So I'm going to drop the absolute value bar because technically absolute value bar means plus or minus. So I'm going to drop the absolute value bar. I'm going to transition that plus and minus into, or I got to account for that absolute value with a plus or minus to the right side here. Now, what does C represent? C is a constant. What type of constant can it be? Positive and negative, right? So that plus or minus will just kind of get sucked into that C. We don't need that plus or minus anymore because that C will handle all positive, negative values. So we can now drop the plus or minus because we have C there to absorb that those combinations. So now we're almost there. To solve for y, what can we do? Let's subtract 1. Okay, now we can't let that 1 get sucked into that C because C is being multiplied. So we'll just have to leave that 1 off to the side. So y is equal to C e to the x squared over 2 minus 1. So this is our general solution. Right. A lot of algebra steps after the calculus, but we'll spend a lot of time practicing it. Right now, I just want you guys to be able to feel like you can follow along and that each step makes sense. Okay, let's look at number 3. Number 3 says, find a general solution for 2x plus 3y, y prime equals 0, then find a particular solution if the solution passes through the point 1, negative 2. So now we're going to go through the full process as before, and then they're giving us an ordered pair, so we can upgrade our general to a specific or a particular solution by involving the ordered pair and solving for C. But first things first is we do want to separate the variables. But something that we haven't quite done yet is dealing with that y prime. So what we're gonna do is we're gonna rewrite y prime with something that's more detailed or more descriptive for us. So whenever we see y prime and we're trying to solve a differential equation, it helps if we just rewrite as dy dx. That way we have all the pieces that we're normally associate with, and we can kind of follow all the steps as before. Okay, so I'm going to rewrite the problem here. 2x plus 3y dy dx equals 0. Okay, I want to get it to a place where I can cross multiply. So I'm going to put the two terms on both sides of the equation, line it up, and then I can cross multiply once I get a fraction equaling to a fraction. So I'm going to do this. Okay. And I can put what under this negative 2x? Over what? Over 1, right? That way I can kind of see more clearly, okay, if there's my diagonal, there's my cross multiplying that I can do. Okay, your cross multiplying will not separate the variables potentially, but it will get your dy and dx's lined up nicely. It will get your anchor variables lined up. Good so far. So our dy dx's are lined up. That's good. That's our first priority. Second is, okay, so now we want to look at the problem and say, do we have full separation? Are the y's together or the x's together? Yes, so we do have full separation. I do want to point out something that I like to do with a problem like this is ultimately, we're trying to clean up the left side. Okay, after everything is done, we're gonna have to move everything from the left side over to the right. I like to take care of things beforehand. If there's anything that I can do to move unnecessary things to the right side of the equation, I'm going to go ahead and do that, even though we can move to our calculus step at this stage. But eventually the 3 has to come over. So anything that I can do a little at a time. I just feel like that's less work down the road. So I'm going to go ahead and divide by 3, because that 3 eventually has to come over. So we either do it now or later. I'm just going to do it now. So I like to leave that left side as bare as possible. Whatever does not have to be there, I'm going to go ahead and move to the right side. And I don't like to have a number below my variable, so I'm going to push it out as a coefficient, even though I could put it below, but it just makes it easier for my next step, for my power rule. I don't have to stare at the number below my variable. Okay, so now everything is nice and clean, right? Okay, so now we're ready to move on to our calculus step, take the antiderivative. Okay, before we jump into our integral rule, let's just talk about what rule we're going to apply here. What rule will be appropriate for this side? Power rule. How about the right side? Good, both are power rule, right? No expansion, no u substitution, no messy rules. Okay. All right, so y becomes negative 2/3 x becomes coefficient stays times what? No. Plus c. All right, do some cleanup here. I get y squared over 2 is equal to negative 1/3 x squared plus c. Okay, I'm gonna have to solve for c. Once you have that c show up, you can plug in and find c at any point in time. Okay, but the way that I'm thinking about it is I'm going to try to get my equation to be as easy for me to plug in. So I would like to just go ahead and resolve my this left side as well before I plug in. I just don't want to deal with as fraction as possible. And also we kind of can clean up along the way. So once your plus c shows up, you have a lot of options in front of you. You can either solve for c now, you can solve for c later, you can try to get the equation cleaned up before you solve for c. So, everyone may have a different order of doing things, okay? But for me, I'm going to maybe try to do a little bit of cleanup. I'm gonna, again, we have 2 priorities now. The 2 priorities, you can do it in any order. We got to get that left side as cleaned up as possible down to y equals, and then we also have to solve for c. So everyone may have a different order that they want to do it. But here, I'm just going to distribute that 2 through. At least I can work towards getting that left side a little bit cleaner. And also the cleaner, the simpler your equation is, the easier it is to solve for c, because you're just not going to have to do as much algebra to get there. Okay, so if I distribute the 2 through, I get negative 2/3 x squared. And then plus what? Good, c. That 2 and c is just going to be a c, right? So plus c. Now, we eventually have to get it down to a square root. We do have to solve for y, but I would like to solve for c before my square root shows up. It just feels easier at this stage to solve for c without dealing with the messiness of square roots. So I'm going to take the time now to solve for c. So again, every problem I may choose to solve for c at a different point, but I'm just trying to go down the path of least resistance. Whatever is the easiest thing for me to do, or the easiest algebra step to do, I'm going to try to do it at that stage. Okay, so what can 1 plug in for? X. Okay. And then the -2 will go in for the y. Okay, so this will go in for the x. Let's go in for the y. Okay, so -2 squared. All right, so I have 4 plus 2/3 equals c. It's the same thing as 12/3 plus 2/3, which is my c value. Okay. So now I'm going to take this 14/3 and do what with it? Plug it back in for c. Now there's a bunch of c's here. You're going to plug it in where you started to make the substitution. Okay, so make sure that you plug it into not anywhere there's a c. Make sure you do it where at that level where you started making the substitution. Okay, so wherever that is, that's where we're going to make that substitution back in. So this 14/3 will go in here. All right, so y squared equals almost there. We do want to solve for y because it did say find the particular solution for y. So to get to y, what can we do? Take the square root. Doing a square root of an equation here, it's going to happen when we take, yeah, there's going to be a plus or minus that shows up. Now, that plus and minus represents us that these are two separate functions, right? We can't include both the plus and minus because then it's no longer a function. It won't pass a vertical line test. So we have a decision to make. Okay? Which function will be more appropriate for our answer? That's what we're going to have to explore. And it can't be both of them. It's only going to be one of these. But are we good so far? Okay. So now it's asking, okay, how do I know which equation that I want to use? And then the big hint is going to be this. It's got to be something that this order pair is part of. So that means if I plug 1 into the equation, into the right equation, I should get a -2 in return. Right. So the only way I'm going to do that is, the only way I can plug in a 1 and get a -2 in return is if there's a negative that's sitting out here waiting for it to be negative, right? Because we know a square root can never be a negative. So the way that we tell, if you're deciding between plus or minus square root, you look at the y value. Whatever the sign of the y value is going to be the one that is going to be appropriate for this. So I have a -2 as my y value, so therefore I'm going to choose the negative square root. And the reason why, again, is because if I plug 1 into both of these, this one will give me a +2. This one will give me a -2. I know a positive square root will never give me a negative because it's a square root, but the negative in front will allow this to be a negative because whatever I get in return from the positive here will turn into a negative. Okay, next page. Okay, find a general solution to y prime equals 6 cosine of pi x, then find a particular solution that passes through order pair 1, 2. Okay, so first things first, let's get this to be more descriptive. Replace y prime with what? Dy dx. Okay, I'm gonna try to set things up so I can cross multiply here. So gonna get it to look like fraction equaling a fraction. And if I don't see a fraction, I can always put a 1 underneath that numerator. Okay, next up, let's do what? Cross multiply. It may not get you full separation, but it will get the dy dx's in their right places. They'll kind of act as our anchor variables. Okay, so now we take a step back and we ask, okay, our dy dx's are lined up. That's good. We know that those are in their right places. Now we want to look at the rest of the equation. Do we have full separation here? Are the y's together? Are the x's together?
Yes.
Yes. Okay, so that's good. Is there any leftover that we should move from the left side to the right side? No, this is as bare as possible, right? We can't do anything more. This, even if we wanted to clean it up, there's nothing more to move. Okay, so this is as cleaned up as we can go. And now we're ready for our calculus step. Okay, full separation. Now we want to get it out of derivative form into the function form. So include the integral notation. Okay, before we do the integral rules, let's just talk about what rule we can expect to use here. At the left side, we can just expect to use what?
Power rule.
Power rule, okay. The right side, how about the right side here? U substitution, and the U value being what? Pi x. And if, hopefully this would turn into a cosine of u du, and we can do integral of cosine, right? Okay. So that's what's ahead. That's where we're kind of heading towards. Okay. So we'll do one side at a time. We'll take care of the left side first. Y becomes I squared over 2. We'll hold off on that because looks like we have some work to do on the right side. So let's do the steps necessary on the right side. We said our u value is pi x, so take the time to go through your u substitution. What's pi x's derivative? Cross multiply. Continue to work on that left side. I can pull the 6 out. Cosine of u times du over pi. Okay, no x's to cancel out. That's good. What can we push out in front?
6 over 5.
Good. Pi is a number, right? So it's okay to push that out. Coefficients out in front. We have a nice clean rule in front of us. What's cosine's antiderivative? Positive sign. I know we're always going to wrestle with that because we're so used to derivative rule, but cosine's antiderivative is going to be a positive sign. Then replace the u back in terms of what? X, yeah. So from the previous unit, this would just be a full problem by itself. But now we see, oh, this is, we're just, this is only part of the process here, right? We haven't gotten to the end of the problem yet. We've taken care of the right side. We've taken care of the left side, but we still have to solve for C. We still have to solve for Y. So we still have a few more things to do. All right. Any questions so far? Okay, but at least we're done with the calculus. We're now at the function level, but still 2 more things to do. We got to solve for Y. We got to solve for C. And everyone is just going to have to kind of decide what order they want to do it in. I have a preference, but it just depends on the problem. Sometimes I'll do one earlier than the other, but It really depends on what I see in front of me. So everyone just kind of has, there's no right or wrong way to do it. You just know you have two goals in front of you, and so you won't get points taken off because you did one before the other, or you didn't do it the same way that I did it. As long as your process is right, you can get to the answer in multiple ways. So, but for me, I'm going to kind of do a combination of two things. I know I have to solve for y, and I find that it's a little bit messy to plug 1, 2 in when I have to deal with a fraction. So at least I can get rid of this fraction before I plug in the order pair. So my preference is I'm going to try to solve for, or at least get this left side a little bit more cleaned up before I involve the order pair in solving for C. So I'm going to multiply by 2. Okay, so this cancels out. What does this become? Was 2 times this. 12 over pi, right? Plus C, yeah. Now we could go further, and eventually we're going to take the square root, but I'm going to solve for order pair before the square root. I just find that the order pair with the square root just feels harder or feels messier. I find that this is a little bit cleaner for me to plug in the order pair. So that's my reasoning. I'm just going to get to where I think is the easiest place algebraically for me to solve for C, but everyone can kind of make their own decision. So replace x with 1 with x, in for x, and replace 2 in for y. So 2 squared equals 12 over pi. Sine of pi times 1 is pi, plus c. Okay, let's think about unit circle values here. What's sine of pi? 0. 0 times anything is still 0, right? So that's nice. That's going to wipe this whole thing out. Okay. So c is equal to what? 4, right? So c equals 4. So I'm going to take that and plug it in for the equation. There's a bunch of c's here, but just make sure that you know where you're plugging it in, right? You're plugging it into where you started making your substitution in for your order pair, right? So this is going to go here. Make sure you're not putting in another place. All right, almost there. We solved the differential equation. We got it out of the derivative level. We solved for c. And now we have one more thing to do. We need to solve for y. So to solve for y, we can do what? Square root. And again, what shows up on the right side? Plus or minus, though. These are two separate solutions. We can't present both as our solution. Only one of them will work. And also, we only are looking for one function. So I'm going to write them both out, and then we can circle the one that we think is going to be the right one. So to decide between these two, we look at the order pair, and what do we look at to decide what we choose? Good, the y value. Okay. If I plug 1 in, I got to get a positive 2 in return. The only way I can get a positive in return, the square roots are both going to produce positive, but then this one will ensure it's a negative. This one will keep it a positive, so we're going to keep the positive one. Y value of the order pair is going to help you decide which one to keep. Okay, so you guys have homework. Your homework packet from previous has these in there, has 6.2, 6.3, 5.7. So check your calendar for the homework problems. Okay. All right, come get your phones. Or they actually convert this to.
Yeah. Okay, and then the other one was, this pricing. Yeah. So what did it do? Like,
It's the rate at which the dog has, behavior has changed. Yeah, rate change. Thank you. So,
and the kid are not allowed to say.
yeah, well, I make. Yeah, so
Okay.
just. Thank you.
Okay.
Yeah, thanks.